I'm Bernardo Strassburg. I'm the founder and chief scientist of re.green, a company that does one thing, basically, ecological restoration at scale. And ecological restoration is the process where we go to a degraded area and we use actually algorithms to identify the most promising areas for impact for climate mitigation, so the amount of CO2 you could sequester if you were to restore that place, the contribution for biodiversity, reduction of extinctions, but also the financial viability. We have predictors for how expensive it will be to restore in that area. And our algorithms combine all this. We started in Brazil, and we actually cover every single farm in Brazil with our database. So we know for every farm what would be the potential to apply the kind of solution that we developed. We managed to develop algorithms that, given a certain climate, soil quality, terrain, future climate projections, on each parcel of the land, we can have an estimate of the type of forest that would regrow if we were to restore, or other ecosystem. This is not exclusive to forests. And by being able to predict that, then we can also estimate which species are going to be there. So we have a catalog of over 4,000 species of endangered plants and animals, and we know where each of them could come back to. And all that is fed into the algorithms to identify and predict the outcome. A lot of further development and more science can come in. Very excited about many of the talks we saw here about using AI. We use a bit of machine learning. There is a lot to come in the next few years. And also in terms of visualization, which I think would be really interesting. But even before all that, the algorithms we already have today allow us to predict with a high degree of accuracy how viable a particular farm or a particular area would be for restoration. And once it does that, there is a second set of algorithms that look at that farm and try to identify the ideal blend of over dozens of restoration approaches. So you can tap into nature's natural regeneration power and do a very light touch restoration, which is very cost effective. But not all places have still that ecological memory to come back. In these other places, we might need to do more active restoration, and that multiple methods for that as well. It might involve dispersing seeds, and that should be enough, all the way to actually planting over 1,000 seedlings per hectare. This second set of algorithms, based on the data for that farm, identify the ideal blend. So unlike perhaps previous restoration efforts where one method was applied for a whole project, we actually have farms where we have 17 different methods being applied in different parts of the farm. And that brings a huge increase in cost effectiveness. We actually published a paper before creating the company that showed that using these algorithms increased the cost effectiveness up to 6 times. That's 6 times more impact for climate or biodiversity per dollar invested. So a gigantic evolution in cost effectiveness. And I think what we're trying to do with re.green, and succeeding so far, is to tailor what you call this very artisanal method, detailed, place-specific, with all this data and computing power, but in a scalable manner. So I think that's the advancement that we try to create with re.green. It's something that delivers high quality at scale. Before re.green, you had companies that would deliver at scale reforestation of single tree species planted in a row. Or you have this amazing heroic efforts, usually by NGOs and academics, at very small scale, would do a very detailed work. What we try to do is maintain the quality of this, but through a company that can deliver at this scale by tapping into science and technology. Science and technology plays a huge role into that. But the other one is a more trivial approach, is that we operate in Brazil, which is a large country, multiple different ecosystems, multiple regions. We see each project as its individual project with its own characteristics, and the data helps, but also I think the company's approach to recognizing that that socio-ecological system is unique. You're not going to implement a single formula. It is more expensive than planting a single species in a row everywhere, as pulp and paper companies do for eucalyptus plantation, for example. But once you do that, the quality of what you're producing is much higher. And what has changed perhaps in the last 4 or 5 years is that the market is now ready to pay for quality. To give an example, one of the sources of income that re.green taps into are the carbon markets. And we do not deal with those seeking low quality, low price carbon credits. What we do is too expensive for that. But more and more you have companies that worried about their reputation in what they're buying. We can see many news articles about low quality credits, and that sometimes bogus claims to mitigation efforts by company, how that damage reputation. So companies that were wary of their reputation, they are looking for high quality climate mitigation projects. And when you help to rebuild an ecosystem, and re.green only does what the Society for Ecological Restoration calls a 5-star ecological restoration. All types of restoration are useful, as hotels of 1, 2, 3. But a 5-star ecological restoration is when you fully restore the composition, the structure, but crucially, the ecosystem functions of a forest. And that's what allows that forest to, for instance, suffer with drought or even fires, but come back. And that, for the permanence of your climate mitigation effort, for you to claim that that carbon you remove from the atmosphere is really now stored in the vegetation, that makes all the difference. We have no interest in an approach that would be different than this, that would restore a forest that in 30, 40 years would go back to the degraded state. So the analogy is perfect. And the difference is most children, I believe, would learn to ride a bike in a few months or a year. And our projects actually have 30 to 50 years in duration, because we really want to make sure the forest went to that stage where we can say ecosystem processes are restored. This is resilient. It can go now.